Hi guys, welcome back. I hope all of you are doing good. So guys, before we get started, please let me know if you all can hear me and see me clearly. Please type it down in the comments. And with that, let us get started. So guys, as you all are aware, we'll be starting off with a year-long course in YouTube starting from June 4th. And this warm-up series is a preview or prequel to that. Okay? So here we are looking at topics that will help you to transition into 11th standard very easily. Okay guys, so today the topic of discussion is going to be logarithms. We'll learn how to solve log questions in a quick manner and I will teach you some unique approaches. Okay, so let us focus on some properties. We will learn what is log. We will solve some questions. Let's have a great session guys. Okay, so before we get into the topic, I would like to introduce myself for all those who do not know me. So my name is Shimon Joseph. I am a BTech and MTech graduate from IIT Madras. I've been teaching for almost 6 years now, mentoring over 5,000 amazing students like all of you watching this. And guys, when I was like you guys, a few years back, I too took the JEE Mains and the KVPY exam. So that is a quick intro about myself. With that, let's move to the topic. Okay, so before I get into the problem solving, let's learn a little bit about logarithms. Why is log there? What is logarithm? How do I relate to what I already know? Because always we have to get a feel of the subject, right? Only then it's easier for us to understand. Let's do that. Let's do that, shall we? So first, before I introduce logarithm, let me give you an idea of what exponential functions are. I'm sure all of you are aware of exponential functions. So exponential functions are those which are of the form a to the power x. Okay? So what are some examples? Can you guys tell me? So let us look at 2 to the power x. 2 to the power x is an example of exponential function. What is the other example? I can say 3 to the power x, I can say 4 to the power x and so on. They are all called as exponential functions. Okay guys, please note that in exponential functions, you will never have something like this. You will never have minus 2 power x. You must have noticed that because it is not defined for all values. Let us say I say my x is equal to 0.5. So that means what? Square root of minus 2. Is square root of minus 2 defined? Did you guys anywhere in your 10th standard study roots of negative numbers? Of course not, right? So let's not worry about exponential functions right now because we are going to look at log. The only reason why I am talking about exponential is because we can correlate log and exponents. That is exactly what we are going to do. Okay? So the only thing which you have to know right now is in exponential function, my a cannot be negative. Is that clear? Superb guys. Now let's look at some examples of exponential function. I will take 3 power x because I like it. So let's write 3 power 1. What is 3 power 1? That is 3. What is 3 power 2? 3 power 2 is 9. 3 power 3 is 27. So this is my exponential function and this is how I write them. All of us are aware of it because we have been studying exponents right from our 6th standard, isn't it? So now how do I bring in log? How do I bring in log? So guys, look at this example clearly. You have 3 to the power 3 is equal to 27. Now, let me remove that 3 on the power. What will I do? I will write it as 3 to the power x is equal to 27. Now I will pose a question to you, to all of you. How do I find this x? That is where log comes into picture. So this example is pretty easy, right? All of us know what is the power of 3 that will give me 27. All of us know that. So this 27 can be written as 3 to the power 3. So since the bases are same, we will equate the powers, right? We will equate the powers to be like this. And that is how we get the answer. But guys, now without doing this, suppose for a complicated equation, how do I get my x? And that is the job of logarithm. That is where log comes into play and makes our job very easy. Okay guys, so this expression 3 to the power x is equal to 27. How can I write it in terms of log? Can anyone comment it down? I'm sure all of you are excited about this. Many of you might be knowing the basics of logarithm. So if you guys do know it, please comment it down below. That will be awesome. Okay. So how do you write 3 to the power x is equal to 27 in terms of log? That is my question for all of you. Okay, so let me write it down for you. The way I write this exponent in terms of log is like this. Log to the base 3. What is the base here? The base is a, right? Base is 3. So log to the base 3 of 27 is equal to x. That is how you convert them. That is how you convert them. Guys, this is very crucial. You should be super comfortable converting exponential form to logarithmic form. Okay? So log base 3 27 is equal to x. That is the form, logarithmic form, and this is the exponential form. Getting it? Are you guys able to get the hang of it? Don't worry, we'll do lots of examples so that by the end of this class you will all be comfortable with log. Okay? That is the intention. That is the objective for today. I'm sure all of you are on the same page with me. Okay? So let me erase this so that we'll look at some more examples. Now I will give you a homework, guys. Now I want you to write what is 4 to the power x is equal to 64 in terms of log. Okay? I want all of you to write it down. I don't want you to find the answer. I'm sure all of you can find the answer. That's a 6th standard question. Everyone can do that. But how do you write it in terms of log? How do you convert this exponential form into a logarithmic form? That is my question. Quickly guys. Comment it down below and let us get going. So how will I write this? This can be written as log, what is the base here? The base is 4. So log to the base 4, 64 is equal to x. So that means what? This, the way I understand this is 4 raised to the power x is equal to 64. Or in other words, x is the power to which 4 must be raised so that it gives me the value 64. Similarly, x is the power to which 3 must be raised so that it gives 27. That is how you interpret it. Okay? So now this is the basics of log. By now I hope all of you are comfortable. If you want, I can give you some more examples. So we can take 5 to the power x is equal to 625. So what can I say? I can say that x is equal to log to the base 5 or 625. Okay guys? So that is how you solve or convert them from one form to another. So what will be the answers? Let's get the answers. This is 3. This is 4, I guess, and this will be 3 again. Okay, perfect. Now before we proceed into solving, let us try to appreciate log. I want you to understand what is the application of logarithms. Okay, although it's not necessary for us to solve questions or become an expert in maths, let us try to take some time and see the applications of log. Okay guys, so let's do that quickly and then we'll move forward. One of the most important applications of logarithm is the scale, the scaling factor. So suppose guys, I want to observe what happens to earth in 1000 years, 2000 years, 10,000 years, 100,000 years, 1 million years. Okay, so how do I plot the graph? So let us say I have a graph like this. This gives me time. And let's say in my y-axis I plot what happens to earth. Okay. Let's say global warming, it's a famous topic, right? So let's focus on that. So you have time axis and you have the y-axis which says what happens to my earth over time. So now where are we? We are in 2000, right? 2019. So I want to study what happens at 10,000 and I want to study what happens at 100,000, and let's say you want to study what happens at 1 million also, or 10 million. Okay. So now if I plot it in a linear scale, like how we plot in school, right? We take a graph and then we plot x-axis, y-axis. We'll write in the top scale is equal to x-axis 1 unit is equal to 5 centimeter, or 1 unit is equal to 1 centimeter, something like that. We write scale in the top of the graph sheet, right? Otherwise our teacher won't give us marks. So something like that. Here I cannot write linear. Why cannot I write linear? Because if I start writing linear, where is 10,000, where is 100,000 and where is 10 million? It's a huge number, right? So if I keep going, it will be very much spread out. But here is where log comes into picture. So if I write 100 to the base 10, what is that? 100 to the base 10, what is that? That is going to be equal to how much? Can anyone tell me? Let's say it's equal to x. All of us will solve it. Now this is logarithmic form. So how do I convert it to exponential form? Just now we learned that is going to be 10 to the power x is equal to 100. So x is equal to 2. So such a huge value 100 in logarithmic scale becomes 2. Becomes 2, just 2. So let's write what happens to log 10 of 1 million or 10 million, let's say 10 million. So what is my x? My x will be 1, 2, 3, 4, 5, 6. It will be the number of zeros, right? So it will be 7. It will be the number of zeros because here log 100 to the base 10 will give you 2 zeros and log 10 million to the base 10 will give you 7 zeros. So if I change it to logarithmic scale, I can plot it very easily, right? I can plot 1, 2, 3, 4, 5, 6, 7 and I'm done. Because that is what I want to look at, right? I wanted to look at till 10 million scale. Now I have a linear scale because of my log. My log can play with scales. It can even represent very high values and it can represent very small values also. That is the beauty of log. Okay guys? So I hope all of you have got some of the applications of log. There are lots to it. So especially when you are dealing with sound units, decibels, right? So you can have very high value or high magnitude of decibel and low magnitude also. So all of this can be accounted for in log very easily. Okay, these are the applications of logarithm. Now let's move on to questions. Okay. So before we get solving, you have to know the properties, right? So let's look at the properties of logarithm. The first one is what? You have log of a base c plus log of b base c is equal to log ab base c. Is that clear? So now I will give you some examples. Of course we are not going to derive them. It's not necessary. These are the 4 basic properties which I would appreciate if you guys can remember. These are very useful in solving questions. And before we get into questions in a few minutes, let us look at properties guys, because I want all of you to be able to solve them. Okay. So now I will tell you how to use them. Okay, let's look at first one. So you have log a to the base c, right? So let me take an example. Let's say you have log 5 to the base 10. I'm taking base 10 because all of you are comfortable with base 10. At least those who know a little bit about log. Okay, so log 5 base 10 plus log, let's say 20 base 10. What is that going to be? So according to this property, when I have addition symbol in between two log which are to the same base, I can combine them. I can combine them by multiplying them to the same base. So this is going to be how much? 2, because 5 into 20 is 100 and log 100 to the base 10 is going to be 2. That's it. That is a simple illustration of how to use the first property. Is that clear to everyone? Brilliant guys. So now the same example, if I do it, how do I solve it? So let us do the same example with respect to property 2. So let's say log 5 base 10 minus of log 20 base 10. So that will leave me with what? Log base 10. 5 by 20. So when you have subtraction, you will combine them by dividing the values. You will be combining them by dividing the values 5 by 20. So this will be what? This will be 1 by 4 to the base 10. Clear? Brilliant. So now third property, again we'll look at it with an example. It is very important guys. Third property is quite frequently used. So what is the third property? If you have the base raised to any power, it will come out as reciprocal. Okay? If you have base raised to any power, it will come out as the reciprocal. Let us have a look at that. What do I mean by that? Let's say you have log 3 to the power 5 and 4 to the power 9. So how will that be? That will be reduced to 9 by 5 log 4 base 3. That's it. So what did I do over here? Log of 4 to the power 9 base 3 to the power 5. Now whenever I have power in the base, what did I say? It will come out as reciprocal. So it comes out as 1 by 5. But whatever power I have in the number over here, that will come out as 9 directly. Okay? Brilliant guys. So that is how you use the property 3. Now let's go to property 4. What is property 4? Property 4 is change of base. Very crucial, very helpful in solving questions. Okay. So this would be the increasing order of importance. So I would say this is very important to solve questions. Let us see how it is applied, and I will derive something else which is not given here. So listen carefully guys. So you have log a to the base b, that can be written as log a to base something. It can be whatever you want. Just make sure that it is positive and not 1. Okay guys. This log a to the base x can be anything. This x can be anything. So that is why I call it change of base. Here what is the base? Here the base is b. But here what am I doing? I am changing it to some x, which can be whatever you want. Just make sure it is positive and not 1. Okay. Similarly, divide by log b to the base x. So this is property 4. But now, can I write this as 1 by log b to the base x by log a to the base b? I'm sorry, a to the base x. Can I write this guys? Is that fine? All of you okay with it? I just brought this term to the denominator. I divided it in the denominator. Okay. So now, can I say this is nothing but 1 by log b to the base a according to property 4. So here we have something amazing. So log a to the base b is nothing but 1 by log b to the base a. Another good result. I can use this while solving. Okay guys, all of you clear with it? Perfect. Awesome. So please make a note of it. These are some important properties which you should be knowing before we get into numericals. So let's get going. I'll close this. I'll move to the next page. So this is a very important property, and that is why I separate slide for it. And many people get confused in this. So I want to spend some time here and derive this alone. The reason I want to derive this is because when you derive it, you will never forget it. Okay. So you guys can take your pen and your note, start deriving with me so that we won't forget it. Okay, so let's get started guys. So this property says that a to the power log c base b is equal to c to the power log a base b. Okay, so what is happening here? These two are switching. Can you see that? A and c are switching, right? So that is something amazing, not intuitive. You will feel that, is that correct? Does that happen really? That is what we tend to think, but actually it is true and we can even prove it. So let's prove it. So I will take this to be t. Okay, so let's take log of t. What is log of t? Log of t is nothing but log of a to the power log c base b. I hope all of you can agree that. I took this as t, I took log, don't worry about the base. Let's say it's anything. Don't worry about the base, let's say it's anything. Okay. Is equal to log of a to the power log c base b. Now, according to log properties, whenever I have power in the number, what did I say? The power will come outside. Isn't that right? So let's do that. So I'll take the power alone outside. What is the power? Log c base b. Okay, that is coming out. Now what is left out? Log a is left out, isn't it? Log a is left out. Now log c base b, from change of base, can I write it this way? Can I write log c base b as log c by log b? And can I combine these two? What is log a to the base something divided by log b to the same base? That can be clubbed together as log c is already there, multiplied by log of a base b. That is something good. So these two I clubbed and made it log a base b. That is super awesome. Okay. So now what can I say? I will bring this in the front. Okay. So let's see. It says multiplication, right? So instead of ab, I am writing ba. Multiplying one with other. I am just bringing this in the front so that I can reduce to a nice form. Look at it guys. So this will be what? I will write it down over here. This will be log a base b log c. So this is like a number which is multiplied in the front, right? So can I take it to the power? Can I take it to the power? Because this is the number which is multiplied in the front. What did I say? If it has a power here, it will come in the front. So if something is in the front, can I take it to the power? Of course, yes. That's also valid. So guys, this will reduce to what? Log of c to the power log a to the base b. So now, what we started with? Log t. And what have we reached now? We have reached a stage wherein I said that is equal to log of c to the power log a base b. Now obviously I can compare them by removing log, right? So what is t? T is equal to c to the power log a to the base b, and t is also equal to a to the power log c base b. That's it, we have proved it. So please have a look at it, guys. It might get a bit tricky over there, so please spend some time and go through the properties which I have given you and correlate them. This is super useful. This is a good property. Okay. So if you have any doubts, you can comment it down. So let me just go through it again once more so that all of you can understand this. So first I took this as t, okay, because I want to prove this. So I'll start with LHS and then I'll reach RHS. Okay. So this, if I take t, what did I do? I applied log. Log to the base what? Log to the base anything. Don't worry about it. So I'm just using the properties of log to prove it. So log t is equal to what? Log of this number, because that is only t. But when I have log of some number to the power, that power can come in the front. So I brought the power outside to the front. So what is the power? Log c to the base b. Now log c to the base b can be reduced as log c by log b. Okay. And log a is left out. Clear? Now log c I keep it as such, and then I want to combine log a divided by log b. Why? Because I want to switch, right? So obviously I want to keep it separate and combine these two, because log ab is together. Okay, are you getting it? The way it proceeds. Now log c into log of a by log of b can be written as log of a by b. Now I bring this log of a by b to the front. That's what I did here. Log of a by b I brought to the front into log c. Now if something is on the front, can I take it to the power? Yes, of course. That's what I did. Now compare. Log t is equal to log of this. Log and log can be removed. This log and this log can be removed. So t will be compared to whatever is inside. That's it, done. Okay. So I hope all of you got it. Please take a screenshot. If you did not understand it, you can go through it later on. Let's move to questions, guys. It's time. Perfect. So let's start off with the easy one. I want all of you to try it out. Prove that 1 by log ABC base A plus 1 by log ABC base B plus 1 by log ABC base C equal to 1. So let us try to prove it quickly. Okay. So all those who want to try, please pause the video. You know the deal. So pause it, try it, and then come join us. Perfect. So let's do this. So what is the first property I'll use? So let me take a pen. The first property I'll use is reversing them. So when I reverse them, I hope all of you know this, right? Let me write it down for you. Log ABC base A is equal to 1 by log A base ABC. Do you guys agree with me on that? Do you guys agree with me on that? What is the property I'm using? I'm using property 4. Property 4 I'm using. Okay. So that is what I'll be using. So what can I do? I can cross multiply. I can take this over here and this over there. So what will happen? I will get log A to the base ABC is equal to 1 by log ABC base A. Okay. So I have 1 by log ABC base A, that can be reduced as log A base ABC. Similarly, I can say this will be plus log B base ABC plus log C base ABC. Now log to the same base ABC, ABC, ABC. What can I do? Property 1. What does property 1 say? If you have addition symbol, you can combine the log if they have the same base by multiplying them. So it will be what? Log to the base ABC, you will have A into B into C. So it will be 1. Why is it 1? Because we know that log of something to the same base is always 1. Because convert it to exponential form and see. Here that visualization helps. A to the power 1 is always A. A to the power 1 is always A. Therefore, log of ABC to the base ABC will be 1. And I have proved my answer. Okay? All of you got it? So shall we get going, guys? We will do a few more questions. I have got some interesting ones. Let's have a look. This is my second question. So we have if ln of 2. Now let me tell you what is ln. Some of you might be wondering why ln is given when we are studying about log. So guys, ln is nothing but log to the base e. So we have something called e, which is called as the Napier's constant. So you need not worry too much about it, guys. Just know that ln is another log, like how you study log to the base 10, right? So here you have log to the base e, where e is a number. Okay, as of now, take it that way and solve this question. Okay, I will give you few seconds time. You can try it out and then maybe we can discuss it. Okay, so now is the time to pause the video. I will start solving, guys. So very basic question. What do we have here? We have log to the base e of 2 into log to the base b 625 is equal to log 16 base 10 into log to the 10 to the base e. Okay, so let us write it down. Can I write this as log 2 by log e? Okay, so let me write it to base 10. What did I use here? I used property 4. I can separate this and write it to any common base. That common base I chose as 10. Now let's solve it. Into log 625 base 10 by log b base 10 is equal to log 16 base 10. It's already in base 10, so I don't worry about it. And that can be converted as log 10 base 10 by log e base 10. Okay, so guys, that's it. We are ready. So log 10, log e to the base 10, log e to the base 10, I can cancel it out directly, and then I have to start solving. What is log 10 10? Log 10 to the base 10 is 1. So I can leave that as well. So let us work with the other terms which are left out. So here we have log 16 to the base 10. Can I write 16 as 2 to the power 4? Okay, can I write 16 as 2 to the power 4? And can this 4 come in the front? So that is the next step. So it will be written as 4 log 2 base 10. Okay, now 625, can I write it as 5 to the power 4? 625 can be written as 5 to the power 4. So can I bring this 4 in the front? Of course I can. So write it as 4 log 10 5. Okay, and then we have divided by log 10b and we have log 210. So log 210 cancel, 4 and 4 cancel. So what do we have? We have log 10 5 is equal to log 10b. So which implies done. Okay, so please go through it. All those who are new to log, you can take some time, guys. I will probably give you some time to take a screenshot. Maybe later on you can go through it. Okay, so guys, that is how you solve it. I hope all of you liked the use of basics and properties here. So that is how you start learning logarithms. Okay, so initially you start off slow, and with time you can solve much greater and tougher questions. So the tougher questions in logarithms usually come from inequalities. Okay, so right now we won't be doing that, but in the long term course we'll look at some great inequality questions. So yeah, keep attending and keep practicing, guys. That is more important. So yeah, let's go to the next one. So this is a pretty simple question. The next type of question, so wherein you have to find x. So basically I have to solve this equation and find the suitable value of x. How do we go about doing that? Let us have a look at it. Okay, so guys, if you want to try, you know the deal. Pause it, try it, come back. Okay, so let's get started. First, I want to simplify it. So here what will I use? I will use property 5, which I gave on the separate slide. You guys remember that? So I will use that. Why? Because here log ax is there, but here log a 3 is there. I don't want something like that. I want same x to be coming over there. So can I write this as 3 to the power log ax? Now is it simple? Otherwise it's a tough question to solve, guys. This is very easy to solve. So this comes from property 5 which I gave in the separate slide. So now it's pretty easy. So we have 3 into this reduces to this, and we have 3 to the power log x base a already there. When you add both of them, what do you get? You get 4 times of 3 to the power log a x is equal to 2. So 3 to the power log x base a is equal to 1 by 2. So 1 by 2 can be written as 2 to the power minus 1. Okay. So now I'll take log on both sides. So if I take log to the base, let's say we take log to the base 3. So if I take log to the base 3, what will I get? We have 3 to the power log of x base a is equal to log of 3 2 to the power minus 1. Okay, I hope you guys can see that. So this will be reducing to log x base a, because the power will come in the front, which will leave me with log 3 base 3, which will be 1. Log 3 base 3 will be 1, so it will be log x to the base a, which will be equal to what? Which will be equal to minus 1 log 3 base, log 2 base 3. Okay? Clear? So now what will be the value of x? It's very easy, right? So what is x? X is equal to a to the power minus log 3 base 2. That's it, done. So that is how you solve it. I hope all of you have got the method. Okay? So guys, if you have any doubt, please do post it in the comments. I will help you out. So let's get going to the next one. So the next question is log of x plus 3 plus log of x minus 3 is equal to log of 27. So if there is no base given, don't worry about it. You can take it to be 10. Okay. So for now you can take it to be 10. So let's have a look at this question. So this is log of, okay, I need to take the pen. Log of x plus 3 base 10 plus log of x minus 3 base 10 is equal to log 10 27. Okay, so guys, they have same base. What can I do? If I have addition, according to property 1, I can multiply, right? So it will become x plus 3 into x minus 3 is equal to log 10 27. So here what can you see? Log 10 is there, log 10 is there, equality is there. So I can remove log 10, whatever is inside must be the same. So x square minus 9 is equal to 27 and x square is equal to what? 36. So what is x? But is both the answer correct? Can anyone tell me? Can anyone tell me if both the answer is correct or wrong? Guys, only plus 6 is correct. Okay. Minus 6 is not correct because log cannot have something negative inside it. Okay. Log can never have something negative inside it. Whatever is inside log must be positive. Okay guys. So that is a rule. We will study more about it in detail when we go to the topic functions. Okay. So that is why plus 6 is the answer. Minus 6 is neglected. You can leave that out. Good. So getting the hang of it finally. I hope all of you are able to follow. If you have any issues, let me know guys. Okay. So yeah, let us solve this question right here. So I will move away so all of you can see the board. This is a pretty simple question, but it makes you get comfortable with the log chapter. Whatever properties we completed, till that it will be thorough. Okay, so let us have a look at it. If in a right angle triangle, A and B are the lengths of the sides and C is my hypotenuse. And what do we have? C minus B is not 1 and C plus B is not 1. Then we have to show that this relation is always correct. Let us start solving this. Okay. So first I will read the question and interpret it. So first I have a right angle triangle. So let's say my right angle triangle is like this. What are the two sides? The two sides are A, B. So hypotenuse is C. So what is the relation I can write? I can say that C square is equal to A square plus B square. That comes from Pythagoras theorem. Okay. Now I want to work with my LHS. From LHS I will reach RHS. That's how I want to proceed. Now guys, please let me know one thing. Do they have the same base? You have C plus B here, you have C minus B here. I don't like it when it's like that, because if they have different base, it's very difficult to use my properties, right? So what will I do? I want to make them same base. So for that I have a very good method. Please look at it. What will I do? I will reciprocate it using property number 4. Because log A to the base C plus B is equal to 1 by log C plus B base A. Similarly, I'll do here. Okay. So now let's take LCM, cross multiply and add it. So if I take LCM, what will happen? Log to the base A C minus B plus log to the base A C plus B divided by log of C plus B into log A C minus B. Okay, this is product guys. These two are multiplied. Okay. So now I have log same base addition. What do? I multiply whatever is inside. So this will be log to the base A C square minus B square. Why is it C square minus B square? Because I multiply C minus B and C plus B. So it is A plus B into A minus B, which is A square minus B square, and that is how I get this over here, divided by whatever I have over there. What is that? Log to the base A C plus B multiplied by log to the base A C minus B. But guys, what is C square minus B square? Have a look at it. What is C square minus B square? That is equal to A square, right? So can I remove the C square minus B square and write it as A square? And if I write it as A square, can I take the power outside? Yes, of course, I can take the power outside. So I can write this as 2 log A base A. And what is log A base A? Log A base A is 1. So I have 2 into 1 divided by this. That's it, done. Why it's done? Because what do we have here? Log A to the base C plus B, right? What do I have here? Log C plus B base A in the reciprocal. So if I want to convert it, I take the reciprocal, then you will get the relation over here, and that is how you prove it. Simple. So guys, I hope all of you liked today's session and you learned something useful in logarithms. And if you have any request from your end, if you want me to cover any specific topic that helps you to transition to 11th as part of this warm-up series, do comment it down below. Okay guys, so about the tough questions, we will look at tough questions when we go into the regular sessions. This is just a warm-up guys. I'm covering the basics to ensure smooth transition. Okay, that is the objective. So I hope all of you enjoyed and learned something. If you like the video, please do subscribe and share with your friends. Thank you for coming once again. See you in the next one. Take care.